I'm Stephanie Schollaert Uz, the Applied Sciences Manager at NASA Goddard. Within the Earth Science Division there, I lead a team that looks for ways to connect our science and observations with societal needs. Our applied research falls under several themes. I'll give examples of projects in which our researchers are applying NASA data to enhance life, livelihoods, and environmental stewardship with partners from operational agencies, universities, and the private sector. A big focus area for us is food security. We have a long history of supporting the U.S. Department of Agriculture, and more recently, NASA Harvest, the Food Security and Agriculture Consortium at the University of Maryland. We leverage NASA observations of vegetation health, water availability, water quality, and air quality impacts on crops. And these are used to improve agricultural decisions. The link at the bottom will get you to these fact sheets in which we link to data sets as well as training and how to use them. For example, observations of water from melting snow, rain, and aquifers and in the soil are observed from NASA satellites and assimilated into the Famine early warning system in partnership with USAID, NOAA, USDA, and USGS. Here, low rainfall in southern Africa in March of 2019 led to low soil moisture, seen on the left, and that impacted the vegetation health, seen on the right, and impacted the early maize season, which led to the prediction of food shortage so they could plan humanitarian aid. Similarly, with 40% of the world's population living in transboundary river basins, we work with the State Department and Department of Defense to help them anticipate environmental conditions that would require diplomatic or military assistance. We support disasters, and this is a view of the disasters portal with near real-time, easy-to-access GIS information on natural hazards. And this can support emergency preparedness and developing mitigation approaches, as well as being easily accessed by disaster response and recovery teams. Many municipalities can't work with our traditional data sets, but they can work with GIS layers. In this example, Hurricane Florence flooding is seen with the European Sentinel synthetic aperture radar, where the blue indicates where there's flooding. And that helps the responders plan their routes when they're rescuing people. One of our research teams supports global chikungunya mapping and forecasting, and this map shows land surface temperatures with chikungunya cases superimposed. So additionally, this group looks at other diseases that impact public health and are sensitive to drought and high temperatures, such as dengue, Zika, and yellow fever, as well as diseases that are sensitive to persistent rainfall and flooding, such as Rift Valley fever, hantavirus, plague, and cholera. Air quality can be monitored from space through nitrogen dioxide, which primarily comes from burning fossil fuels. Changes in nitrogen dioxide levels can be used as an indicator of changes in human activity if the data are properly processed and interpreted. So for example, nitrogen dioxide in 2005 on the left was much higher in urban areas than in 2018 on the right. And this 20 to 60% decrease in nitrogen dioxide levels indicates the success of the Clean Air Act with partners from the Environmental Protection Agency and NOAA. We can also apply NASA data to local efforts. So due to our proximity to the Chesapeake Bay, we meet regularly with resource managers to address water quality issues, including impacts to the growing aquaculture industry around the bay. I'm leading a new project to collect diverse data sets from different sensors to find indicators of poor water quality through data fusion and artificial intelligence. This study is preparing for future space-based hyperspectral sensors. One example is the future PACE mission, Plankton Aerosol Cloud Ocean Ecosystem mission, and that will extend and advance our legacy of observing the global biosphere, from which we study how phytoplankton in the ocean is changing on daily to interannual timescales. With its hyperspectral ocean color instrument, in combination with two small instruments optimized for monitoring aerosols and clouds, PACE will give us new information about phytoplankton community structure and how the base of the marine food web is changing. And this information could be used by our partners such as NOAA in fisheries management, as well as other sustainable development decisions. Applied science is explicitly called for in the current decadal survey for Earth science and applications from space. And that document designates space-based observations of the following variables: surface biology and geology, for example, vegetation traits and health, snow albedo, and mineral mapping; mass change for surface water and groundwater; surface deformation and change for subsidence, snow water equivalent, and flood extent; and finally, aerosols, clouds, convection, and precipitation, which have applications for weather, air quality, health, and climate.